Assalamu alaikum. The new topic for today is series. And before starting the series, there are a few terms which needs explanation. Students must be having understanding of these few terms. And the first term that we should be solving here, understanding here, is sequence. So, sequence, when a set of numbers follow a pattern and there is a clear rule for finding the next number. Clear rule for finding the next number. There has to be a pattern and a rule for finding the next number in the pattern, then we have a sequence. For example, 1, 3, 5, 7, and 9. These are the terms in the sequence. And here, what is the rule? 2 is getting added to every consecutive term. 2 is getting added to every consecutive term here. Second one is 1, 4, 9, 16, 25. So the rule that we see here is that each and every number, each and every term is a squared term. So we can see here that every term is a squared number. So that is the rule for the second sequence here. For the third one, it's 2, -4, 8, -16, and a 32. So let's see what the rule here is. So the rule here is that for every term is getting multiplied by -2. Every term is getting multiplied by -2. 2 into -2, -4. -4 into -2, +8. +8 into -2, -16. -16 into -2, that would give me a +32. So this is what we mean when we come across the word sequence. It has to follow a pattern, and then there should be a clear rule for finding the next number. Let's move to the next terminology. Term. Each number in a sequence is called a term of the sequence. T1 is the first term of a sequence, T2 is the second term, T3 is the third term, and so on and on, so that we can say Tn is the nth term of a sequence, and this can be used to describe any term in the sequence. This Tn, it can be used to describe any term in the sequence. Tn plus 1 then is going to be the term just after Tn, and Tn minus 1 is the term just before Tn. So this is the understanding of term. Like if I go back to the sequence, then I can see here that this is my first term, second term, third term, fourth term, and then fifth term, and just moving on and on up till the nth term. Series. So the third terminology to understand is series. A series is formed when the terms of a sequence are added. Example, 12 plus 9 plus 6 plus 0 plus -3 and a plus -6. So what we know here is that the rule that is getting followed to make a sequence is a -3. For each and every term, we are subtracting the term by -3. 12 minus 3 is a 9. 9 minus 3 is a 6. 6 minus 3 is a 3. 3 minus 3 is a 0. 0 minus 3 is a -3. And -3 would give me a -6, and so on. So all the terms in the sequence when added, all the terms in the sequence when added, they give us the series. We have the first term, the second term, the third term, the fourth term, fifth term, sixth term, and then we have the seventh term, and so on up till Tn terms. So when all the terms added together, we will be having the series here. So a series is finite if it stops after a finite number of terms. Example, 4 plus 7 plus 10 plus 13 plus 6. It stops here. Therefore, it's a finite series. And a series is infinite if it continues indefinitely. Example, 4 plus 7 plus 10 plus 13 plus 16 plus 19, so on, and so on. We do not have a definite number where it stops, therefore, this is called an infinite series here. So, after understanding the terminologies as sequence, term, and then series, let's move on to the first one, which is arithmetic progression. So, arithmetic progression is a sequence that has a common difference d between each term. Arithmetic progression, it's a sequence. It should be having a common difference d between each term. So, what is the rule that applies here? It's the common difference d, and this d has to be added to each term, each consecutive term. Example, if your sequence is 1, 4, 7, 10, I can see that to each term I'm adding a 3. 1 plus 3, 4. 4 plus 3, a 7. 7 plus 3 is a 10. So I can say here that positive 3 is going to be my common difference. Common difference is denoted by D. So this has a common difference, D, which is 3 in this case. Another example, 11, 7, 3, negative 1. Now this is a decreasing sequence. 7 minus 11, that's negative 4. Here again, it's a negative 4. Again, it's going to be a negative 4. So for each term, I can see a negative 4 is getting added to the previous term. Therefore, I can say it has a common difference d of negative 4 here. Therefore, we can say that A is the first term. We usually write the first term with the letter A. Is the first term, D is the common difference, and this common difference is equal to the difference between the two consecutive terms, so that it is T2 minus T1. It can also be T3 minus T2 or T4 minus T3, so on, so that we can say it is Tn minus Tn minus 1, the difference between the two consecutive numbers here. L is the last term in the finite series. If we have a finite series, then the last term in the sequence, that is denoted by L. So this is what our arithmetic progression is. An arithmetic progression with n terms can be written as T1, T2, T3, T4, so on up till Tn. Now, as discussed earlier, we have said that D is equals to T2 minus T1. That means I can say that if my first term is A, then to the first term, if I add a D, then this becomes my second term. Third term, if I add a 2D, D plus D, that gives me a 2D, then this becomes my third term. For T4, it should be A plus 3D, D plus D plus D. Obviously, that would give me a 3D. So the fourth term is A plus 3D up till the nth term, where I can say that it is A plus n minus 1 times D. N minus 1 times d. So what I notice here is that if this is the second term, then the coefficient of d is a 1, 1 less than 2 here. If it's the third term, then the coefficient of d is 1 less of the third term, which is 3, therefore it's a 2 here. And then it's 4 minus 1, that's a 3. So every term, the d should be having the coefficient which is 1 less than the nth term. So the nth term of an arithmetic progression can be written as, so this here can be written as Tn, which is equals to A plus n minus 1 times d. Tn, it is written as A plus n minus 1 times d. So this is the general formula for the nth term here, the nth term of an arithmetic progression. It can be written as Tn, which equals A plus n minus 1 times d. Therefore, ninth term of an arithmetic progression, this is an example that I have just written here. Ninth term of an arithmetic progression can be written as T9, which will be equal to A plus 8d. 9 minus 1, that's an 8. 30th term, it can be written as T30, which is equals to A plus 30 minus 1, that's a 29d here. So this is how quickly, how fast we can just make a term formula for the arithmetic progression. So let's do some examples to get the concept clear for arithmetic progressions. The first term of an arithmetic progression is -6, and the common difference is 5. So find the fourth term and the nth term. Let's do the solution here. First term of an arithmetic progression. The first term is usually written as an A. The first term written as an A is a -6. It's a -6. Common difference D equals 5. And they are asking us to get the fourth term. So by the general nth formula, by the term formula for arithmetic progression, we know that this is Tn, which equals A plus n minus 1 times D. They are asking for the fourth term, therefore I should say that it can be written as A plus 3D. T4 shall be equal to A plus 3D. T4, I should say it's a T4, which equals A plus 3D. Or T4, then substituting A and D, I can say it's a -6 plus 3 times 5, or my fourth term here becomes a 9. They are asking for the nth term also. So to get the nth term, the general formula is Tn, which equals A plus n minus 1 times D. Nth terms means we should be having the equation in terms of n. So I have substituted A and the common difference D, -6 and a 5. Solving it, I am getting Tn, which is equals to 5n minus 11. Let's move to the second question. The nth term of an AP is 7n minus 2. It's Tn, which is equals to 7n minus 2. Find the first term. That means we have to find A and the common difference D. We just have the Tn, the nth term formula, which is 7n minus 2. Asking for the first term, therefore I should know that the first term has the n value, which is equals to 1. Therefore, A shall be equal to, substituting n with 1, it's 7 times 1 minus 2, and my A, or the first term, should be equal to a 5 here. For the common difference, I know that common difference is the difference between two consecutive terms. I have the first term, so D should be equal to T2 minus Tn, T2 minus T1. So to get the second term, I should just substitute my n here with 2, so that this becomes, I'm finding the second term, therefore substituting n with 2, it should become 7 times 2 minus 2, that gives me 14 minus 2, which is a 12. So I have the second term, I have the first term. So the only thing that is now left is to find the common difference, which I can very easily say is 12 minus 5, 12 minus 5, which shall be equal to a 7. Let's move to the third question. The nth term of an arithmetic progression, sorry, the ninth term of an arithmetic progression is 8. So Tn is equals to 8. Fourth term is 18. So T4 equals 18. So find the first term. I need to find A and the common difference D. So I have the eighth term, so I have the ninth term. So I can say it's T9, which should be equal to A plus 8D. I have the fourth term also. So T4 should be equal to A plus 3D. This is by the term formulas that we have already discussed. Therefore, just substituting T9, which is given as 8, I can say it's 8, which is equals to A plus 8D. T4, given as 18, can be equal to A plus, obviously it's 4 minus 1, giving me a 3, 3 times D. I have the two equations in terms of A and D. I can solve the two simultaneously. Doing that, it's 18, which is equals to A plus 3D. And it's 8, which is equals to A plus 8D, and 18, which is equals to A plus 3D. I've solved the two simultaneously by changing the signs. A gets eliminated. I'll be left with 8 minus 18, which is a negative 10. That will be equal to 8d minus 3d, giving me a 5d, or I can say d is equals to negative 2 here. So if I have this value of the common difference, I can substitute in any of the two equations to get the first term, which is a. So I've substituted this d in the first equation, where 8 was equal to a plus ad. 8 will be equal to a plus 8 times d, which is now a negative 2. Solving it, it's a, which is equal to 8 plus 16, and a shall be equal to 24. So this is how this question then needs to be solved. Let's move to another question. The nth term of an arithmetic progression, nth term, Tn, is 1 by 2 times 7 minus n. So Tn equals 1 by 2 times 7 minus n. Write down the first three terms and the 20th term. So writing down the first three terms, that means my n value here, it can be a 1, it can be a 2, and then it can be a 3. So this is a simple question where I just need to substitute n with 1, 2, and then 3. So T1 shall be equal to the first term where my n is a 1, that equals to 1 by 2 times 7 minus 1, 1 by 2 times 6, giving me a 3. Second term, it's 1 by 2 times 7 minus 2, that gives me a 5 by 2. The third term is 1 by 2 times 7 minus 3, gives me a 4. Therefore, it's 1 by 2 into 4, that gives me the value, which is a 2 here. So I have the first term, which is a 3, the second term, which is a 5 by 2, and the third term, which is a 2 here. They have asked us for the 20th term also. So for the 20th term, I should say my n is a 20, and then T20 shall be equal to 1 by 2 times 7 minus 20, or I can say it's a negative 1 by 2 times 13, or I can say that it is the 20th term, which is equals to negative 13 by 2 here. So this is going to be the 20th term. So this is the explanation for arithmetic progression. Hope the concept is clear to all.